Hello everyone. In this video, we're going to talk about how to write equations for trigonometric functions whose graphs we already know. So I found this worksheet online. I haven't done it before. We're going to do it together. Let's get started. So we are going to write this sinusoidal graph into an equation. Using what we already know, we know that the equation we can write can follow this form. Y equals, and we're going to use cosine. So y equals a times cosine of cx plus d plus b. So it's just a matter of using the evidence from the graph to determine which values go in each of these variable spots. So let's look at some evidence from this graph. We can see that the lowest point here is at -10 and the highest point is at 10. That tells us that the midline is going to be at 0. In other words, it hasn't moved from a cosine function that is just a cosine function that doesn't have any transformations. So a regular cosine function will also have a midline at 0. What this means is this graph has not been vertically translated. So b is 0. B is nothing. All right, let's figure out what a is. So to determine a, we're going to look at how far the highest and lowest points are from the midline. Since the midline is 0, we can see that they're 10 away. So the amplitude of this sinusoidal graph is 10. That results from a vertical dilation because normally a cosine function, the highest point would be at 1. So the fact that it goes all the way up to 10 is evidence that there has been a multiplication by 10. So that's going to inform our decision that a is going to be 10. Okay, now we can consider the period. So we need to pick a point. Let's choose this point here. And then let's look for where that repeats. So we're going up here. The next time that we're going up and crossing the x-axis is here. And this distance from here all the way to here is 4 pi. Because that starts at -pi and now it goes all the way to 3 pi. So the fact that the period is 4 pi means that there's been a horizontal dilation. The frequency has changed. So normally a cosine function and a sine function would have a period of 2 pi. Because this period is longer, that means that the frequency is smaller. So it takes twice as long to complete a full cycle of values. That means that the speed of the graph is half as much. It's going half as fast, it takes twice as long. So c is 1/2. So we can replace that. And now to find the phase shift, that's d, what we can do is we can do it kind of intuitively. For instance, we know that we're writing a cosine function, and cosine functions have maximums at 10. So we can see here that there is actually a maximum at 10. And that would basically mean there is no phase shift. Right? Just that is evidence enough to suggest that d equals 0. However, there is a more concrete way of figuring out the value for d. So one thing we can do is we can solve for d by plugging in one of the points that we know is already part of the graph. So for instance here, this point here, this is the point 0, 10. 0, 10. And what we can do is we can substitute these values in for x and y, and that will allow us to solve for d. So let's do that now. We can write 10 equals 10 times the cosine of 1/2 times 0 plus d. So we can now just solve for d. So we'll divide both sides by 10. That's going to give us 1 equals cosine of 1/2 times 0 plus d. Take the inverse cosine of both sides. We get 0 equals 1/2 times 0 plus d. And at this point, right, 0 equals 1/2 times 0 plus d. There's only one value that d can be, and that would mean that d has to equal 0. So we figured out that d was 0, which was what our intuition suggested anyways. So we can write plus 0 in here. I'm just going to go ahead and delete it and omit it entirely. So there you go. That is the equation. Let's do another one. So let's do this one. So the directions here say in terms of the sine function, so we're going to write this as a sine function. We know, let's take a look at the lowest value is at -2, the highest value is at 2. That means that the midline is at 0. In other words, no vertical translation has taken place, so b is going to be 0. We're not going to need a b. We can see the amplitude is 2. The highest point is 2 away from the midline. The lowest point is 2 away from the midline, so we can write that as 2. We're going to write sine here. Cx plus d. So to figure out the period and the frequency, we can just look at, let's say, look here and here, and see how long did it take this function to repeat itself. So from 0.25 pi all the way to 2.25 pi, that's 2 pi. That's the normal period. That suggests that there has been no horizontal dilation at all. So that tells us that c is 1. So if c is 1, we can just erase it. It doesn't need to be there. And then to determine the phase shift, we can just pick a value. Let's see, we pick this point here. That's 3/4 pi. Comma 2. 3/4 pi, comma 2. And we're going to substitute those values in for here and then solve for d. So y is 2. 2 equals 2 sine of 3/4 pi plus d. Okay, so divide both sides by 2, we get that 1 equals sine of 3/4 pi plus d. Take the inverse sine of both sides, arc sine of both sides. We're going to get that pi over 2 equals 3 pi over 4 plus d. We can subtract 3 pi over 4 from both sides, and that's going to give us -1/4 pi, or negative pi over 4, equals d. So that tells us our phase shift here, and we can erase d, erase plus d, and put -1/4 pi. I hope you found that video helpful in how to write equations from graphs of sinusoidal functions, trigonometric functions. If you found this video helpful, please like the video. consider subscribing, and have a great rest of your day.